So number 22 is another solve systems problem. And so again, because both x and y are on the left side of the equation, on the first equation up here and on the second equation down here, I'm going to use elimination. And it looks to me that if we do a little bit of changing, we can probably get the x's to cancel out. So remember from the previous problem, the two things that we need for elimination is for the variable to have the same coefficient, but opposite sign. So if this is a positive 8, we want to try to make this a negative 8. So in order to do that, we just want to multiply the entire equation by 2. And that 2 is going to get distributed to everything. So I'm going to write that right underneath. 2 times negative 4 would give me a negative 8x. 2 times 3 would give me a plus 6y. And 2 times negative 14 would give me a negative 14. And once I'm done with that, I just put a line through that top equation so that I know not to look at it anymore. Okay, so now what you're going to see here is something a little bit different. So like we had talked about initially, we wanted the x's to cancel out or eliminate, which they do. I have 8x and minus 8x. Those are opposites, so they cancel. However, the y's are also going to cancel. I have a negative 6 and a positive 6, so I'm going to put a line through it. However, I can't just leave it blank, so when I have nothing left, I'm going to write down a 0, and then my equal sign. And now also on the right-hand side, you can see that we have opposites. So we have positive 14 and negative 14. That all cancels. So everything cancels this particular problem, and I'm left with this statement of 0 equals 0. And so we talked about this in class. When you get to this point when there's no letters left and it's only numbers, you have to ask yourself this question. Is it true? Okay, and there was a little flow chart. You can either be yes or you can get no. Okay, so in this example I have 0 equals 0. In other words, is 0 the same number as 0? The answer is yes. And so when you have that, it is many solutions. So all that means is that these are the exact same lines right here. However, just to point out, if you got something like this, 0 equals 2, well, that's clearly not a true statement, right? 0 is not the same as 2. If you get that, something like that, a false statement or two different numbers here, then that would be no solution. Okay, so just a reminder that we talked about that a lot in class, but this a lot of times will throw people off when all the letters are gone. Okay, moving on. 23 is a word problem with systems, so this will be take a little bit of work here, but let's take a look. Margie is responsible for buying a week's supply of food and medication for the dogs and cats at a local shelter. The food and medication for each dog cost twice as much as those supplies for a cat. She needs to feed 164 cats and dogs. Her budget is $4,240. How much can Margie spend on each dog and cat for their food and medication? Okay, so on all the previous system problems, we've been given the equations to work with. The only difference here is that we're going to come up with that on our own. And so equation number 1, I'm going to write these out in words first before we start filling in and what the actual letters are. So in equation number 1, we're going to look at comparing the cost of the two different items. So the food and medicine for the dogs versus the food and medicine for the cats. And on equation 2, we're going to be looking at what's the total cost of those items. So basically when you add the two, with the total for the dogs plus the total of the cats. Okay, so if we go back to the problem about midway through, it says the food and medication for each dog is twice as much as those for cats. So for dog, let's go ahead and use the letter D, and for cat, we'll use the letter C. And so let's turn that into equations. So basically dog supplies are twice the cost of cat supplies. So I'm going to say D equals, and if it's twice that of cats, twice is 2, so we're going to put 2 times C. Okay, so dog food is or equals twice the cost of cat supplies. Okay, equation number 2, we're going to look at the cost. And so we're going to use our same variables, C and D. And so I'm going to start by sketching this out. Okay, so there's going to be a number in front of C, a number in front of D, and we need to find what's the total cost. So for all that information, we're going to go back to the question. So it says right here, she needs to feed 164 cats. So there's our first number. So because we're talking about cats, that's going to go in front of C, and I'm going to write down 164. And if we continue on, it says right next to that, there's 24 dogs. And the last part of that says her budget is $4,240. So 164 cats right here, 164 times the cost of cat supplies plus 24 times the cost of dog supplies gives us a grand total of $4,240. So to figure out what method we're going to use, you have to look at the equations. And so looking right up here at the top one, we have a letter all by itself. So to me, I think the substitution would be a little bit easier. So I have my letter by itself. I circle the other side as I did a couple problems ago, and I'm going to draw an arrow to the bottom equation where I see a D. And when we substitute, all we're going to do is put a blank set of parentheses. And in this case, instead of writing that D, I'm going to write down the term 2C. So here's what this would look like. I'm actually going to move over here so we have a little bit more room. So 164C plus 24. Now I'm going to put my blank parentheses, and instead of D, I'm going to write term 2C, and then continue writing the rest of my equation, 4,240. Okay, so number in front of parentheses means multiply, so let's do that next. 164C plus 48C equals 4,240. And then at this point, these are like terms because they have the same variable. They both have a C. So we're just going to combine like terms. So you can check on your calculator. 164 plus 48 gives us a total of 212. Okay, and don't forget the C, our variable, equals 4,240. And as we said a few times on this, when you have a number in front of a letter, the way you move that is by division. So we're going to divide both sides by 212. And if you double check on your calculator, 4,240 divided by 212, you get 20. Okay, so C, the cost of cat supplies, is 20 bucks. Okay, but this is a system, so we need two different values. We have the cat supply cost of $20. We're going to plug that into our other equation because we also want to know how much she spends on the dog supplies. Okay, so all I did here was copy down the first equation I had over here. So now I have a known value for C. I'm just going to plug that in. So D equals 2 times 20. So dog food or dog supplies cost $40. So it's a two-part answer here. Cat supplies equal 20 bucks. Dog supplies equal 40 bucks. Moving on. And make sure you pause that and go back if you need to. There's a lot of work on that problem. Okay, so number 24. Chris has a pocket full of dimes and quarters. There are a total of 17 coins. When she added it all up, she had $2.75. How many dimes did she have? So one little important thing here is to realize that they're not asking for both types of coins. They only want to know how many dimes. So that'll be an issue later on in the problem, but I just want to point that out at the beginning. So again, this is going to be a system problem, so we need two equations. Equation number one is going to look at the total number of coins, so how many coins she has. And equation number two is going to relate to the total value of the coins, or how much, if you add up the value of each of those coins, how much money does she have? Okay, so, and just like the previous problem, we're going to go to the text up here to figure out what those equations look like. And so she has two types of coins. There's dimes, which I'm going to label as D, and there are quarters, which we're going to label as Q. And an important thing to realize, even though they don't point it out, we also know that dimes are worth 10 cents each, and quarters are worth 25 cents each. So we'll see why that's important in a minute. So equation number one, total number of coins. We're just going to write down the variables of the two coins that we have and add them up. So D plus Q. And then we go to the problem, and it says right there she has 17 total coins. So if we to add up D plus Q, we would get 17. Okay, now the bottom part, there's a little trick here. We have to take that information of the value of the coins. So even though they don't tell us that a dime is 10 cents and a quarter is 25 cents, we already know that, so we're going to use that down here. So in front of dimes, I'm going to write 10 because each dime is worth 10 cents. And then over here, even though again they don't tell us, I know that quarters are worth 25 cents. Okay, and here's where the trick comes in play. So this amount right here is in terms of dollars, but this amount right here and here are in terms of cents. So in order to make the math a little bit simpler, we're going to do a little trick and take this dollar amount and convert it into cents by moving the decimal spot 2 spots to the right. So instead of writing 2.75, we're going to write 275. And that just makes the math a little bit easier, because if not, we would need to put these in decimal form as 0.10 and 0.25. And anytime you can avoid decimals is generally a good thing. So we're going to go ahead and do a little cheat on that and not do so. So here are my two equations again, just in summary. D plus Q equals 17, and 10D plus 25Q equals 275. And so you guys can pick at this point whether you want to solve by substitution or elimination. I'm going to choose elimination, and so I'm going to try to eliminate the D's. So if I have plus 10D on the bottom, that means the top would have to be negative 10. So I'm going to multiply that entire equation by minus 10. And let's write out our new equation down here. Minus 10 times D is minus 10D. Minus 10 times Q is minus 10Q. And lastly, we have negative 10 times 17 is negative 170. And so you can see here we can eliminate the D's because we have same number but opposite signs, plus 10 minus 10. So those are gone. And now I'm going to go ahead and finish up the equation. So I have 25Q minus 10Q. That gives us 15Q equals 275 minus 170 gives us 105. And one more step here, we have number in front of a letter, so that means we need to divide both sides, in this case by 15. And that gives us 105 divided by 15 is 7. So that tells us that there are 7 quarters. Now I did this on purpose to show you guys where we could have shortcut earlier. So we have Q equals 7, and we can find out what D is really simply by plugging into that original equation of D plus Q equals 17. So instead of a Q, we're going to substitute in a value of 7. Okay, and then we would just subtract that 7 over. And D, the number of dimes, is, that should be a 7. Right, that was a typo. Okay, and then that should give us 10. So 10 dimes. So this isn't always the case where they're only asking for one of the two variables, but because they were in this case just asking for the dimes, we could have done this one more step quickly by, instead of eliminating the D or eliminating dimes, we could have eliminated the quarters first to initially solve for D, but it doesn't really matter. It wasn't a whole lot of work to find that second value anyways, and it's good practice to solve for both of them. But just a reminder to read the question carefully. If they're only asking for the number of dimes, make sure that your final answer is that variable that they were looking for. Okay, last two problems are pretty straightforward on this page. Number 25 says simplify the following expression. So it says simplify, not solve, so we're not going to get a number answer on this one. There might be numbers involved, but there's also going to be letters involved. And so this is talking about exponents. And so we have 2 to the negative third power times c to the negative third power times d to the 7th power. And so the issue here is these negative exponents. We don't like negative exponents. So in order to simplify that, we're going to flip it or do the reciprocal. And so all that means is that the 2 and the c are going to move into the denominator. Okay, so because d has a positive exponent, it's going to remain just as it was initially given to us. We're going to put a fraction bar, And both of these guys are going to move to the bottom. But remember, once you flip it, you can then turn those exponents into positive numbers. So now that I moved it into the denominator, it's 2 to the positive third power. We're going to do the same thing for c. Okay, oh, should be a 3. Okay, and then one more step. We're always going to try to simplify that number component. So 2 to the third power is just 2 times 2 times 2, which is 8. So there is your final simplified answer, d to the 7th over 8c cubed. And last problem on this page. So this is the stuff we just learned about last week. It says, given the exponential function y equals 0.2 parentheses 4 raised to the x power, state the a and b values. So we're not calculating here, but what we do have to remember is now we're not using y equals mx plus b. Exponential equations are in this format. Y equals a times b to the x. And so a is just your number in front, b is your number in parentheses, so we can simply write a equals 0.2 and b equals 4. So no calculating involved, that's it. A value is the number in front, b value is the number in parentheses. Okay, so we're on the last page of the midterm review and we have 4 more problems left. So let's go ahead and keep going. We have number 27. And this is going to be more exponential equations. So this is all from chapter 4, unit 4 that we just did last week. It says find the equation of the exponential function in the form of y equals ax plus b. So remember, this is different than what we've been talking about for most of the review. Okay, so instead of y equals mx plus b, we're going to say y equals ab to the x. So we want to find the equation that passes through the points 1, 16 and 2, 64. So easiest way to do this is to make a XY chart. Okay, so we need 3 sets of boxes, and we're going to go on the X values 0, 1, and 2. And so to fill in these 2 parts right here, we're just going to go to the coordinates they give us. So it says right here that when, excuse me, when X is 1, y is 16, right? Because we know that it's always xy, the same thing over here, xy. And when x is 2, y is 64. So based on the pattern of these 2 numbers, to figure out what the rate of change is, you're just going to take this second number and divide it by the first number. So if we were to do that over here, that would look like 64 divided by 16 is 4. Okay, so just to note that, the pattern right there is times 4. So we can do the same thing in the other direction. So if as we move to the right, we're multiplying by 4, well, as we move to the left, we'd be dividing by 4. So to figure out what this value right here would be, we're going to take 16 divided by 4, and that gives us a 4. Okay, so it's good just to verify that your pattern continues. So 4 times 4 is 16. 16 times 4 is 64. So that makes sense. Okay, so this value is important. If you remember back a couple problems ago, we talked about y-intercept. Or a different way to think about y-intercept is the starting or the initial value. And so let me write this down and then we'll explain why that's important. So when you're looking at a standard exponential equation in this format, a represents your initial amount or your starting value, and b is your rate of growth. I'm going to write rate of growth, but remember it could also be rate of decay. Okay, so the reason that this is important is that the y value when x is 0 is going to be your initial value. So in this case that's a 4. And rate of growth will be the number that you're multiplying by. So in this case, that's also a 4. So we plug those 2 things in, and it's going to look like this. Y equals 4, parentheses 4, to the x power. Okay, so even though they're the same number, it's important to realize where they each came from. So one more time, the number in front is our initial value, and that's the same as the y-intercept. So if our x value is 0, y is 4, that makes this our y-intercept. That's where this 4 in front comes from. The number in parentheses is the number that you're multiplying by each time. So 4 times 4 is 16. 16 times 4 is 64. So we're multiplying by 4. That's where the number in the parentheses comes from. Okay, 28. Says a bank account has $600 and grows by 4% each year. Which of the following equations correctly models the growth of the bank account balance over time? So again, important to read the question. We're not actually solving this. We're just writing an equation. So I'm going to put some notes over here. So here's our standard form. Y equals A parentheses B to the X. We know that A is our... So we're specifically talking about money here. So I'm going to say our initial money input in the bank. And B is, we talked about that being rate of growth, but in this time we're going to call that our interest, or there we go, our interest. Now it's important, two things to remember here. When you're given a number in percentage like this, you have to convert it to a decimal. And to do that, you're going to move the decimal point 2 spots to the left. So if I'm given 4%, I'm going to move the decimal 2 spots to the left. So that would be 0.04. Okay, but because we're dealing with interest rate, we also need to, because this is growth, we're going to put a 1 in front. So remember, even though they don't both apply to this problem, I'm going to show you anyways, as a reminder. So we can have two kinds of money change. We can have growth, or we can have loss or decline. Okay, you're always going to start with 1. If it's growth, you're going to add the percent increase. If it's loss, you're going to subtract the percent decrease. So remember though, even though I put percent, remember we need to convert it to a decimal by moving the decimal point 2 spots to the left. So in this case, we had 1 plus 0.04, which is 1.04. However, if it said that we were losing money at 4% each year, you would just subtract it. So 1 minus 0.04 would be 0.96. Okay, but we're not doing that on this problem. We're doing it on this one. So our interest rate, or our growth, is 1.04. Our initial investment, if you look back to the problem, was $600. So again, if you look at our standard equation, we're going to go like this. Y equals, the initial amount of money goes first, which is 600. And then in parentheses would be our value right here, 1.04, raised to the x power. And so now we're just matching these up. And so that looks like to me that D is the correct answer. Okay, 29, you got 2 problems left. Okay, it says which functions represent exponential growth? Select all that apply. So whenever you see this phrase, select all that apply, it's a good clue that there's more than one right answer. And in order to determine this, we're going to look at the B value. So remember that it goes like this. So we're only looking at the number in parentheses. So I'm going to go ahead and box these just as a reminder that that's the part that we're looking at right now. Okay, and here's the rule. It's growth if B is greater than 1. So it could be 2, it could be 3, it could be 8.4. Any value that's bigger than 1. It could even be 1.001. Anything that's greater than 1 is going to be growth. Okay, decay will never be negative, but it's going to be anything between 0 and 1. So 1/2, 1/4, 0.37, 0.58. Anything that's between 0 and 1 will be decay. And so in this particular problem, they're looking for growth. So we're only going to circle the options that have a B value, or a number in parentheses that's greater than 1. So in this particular case, that would be A. B would not. C is greater than 1. D is not. And E is greater than 1. So even though this is just a little bit over 1, it's still greater than 1, so that falls into the category of growth. Okay, and the last problem, number 30. A $250,000 car, I'm sorry, $25,000 car, is losing value at a rate of 22% per year. And we're going to do two things here. Number one says write an exponential function that models the scenario. And that'll be a good reminder why it's never a good idea to buy a new car, because they lose value so quickly. And then part B, it says use the function to determine the value of the car in 10 years, which will be further evidence of why buying a new car is the bad idea. So we're going to start over here by writing down our standard form of an exponential equation. I equals a times b to the x. And we're going to remember that a is the start value, and b is the rate of, in this case, I'm going to say rate of decay, even though we're not really decaying, we're losing value, but just to keep the terms constant. So it's our rate of decay, or the rate at which we're losing money. And so back on problem 28, we talked about percentage problems. So we're given a percentage here of 22. And we want to convert that into a decimal. So we move it 2 spots, the decimal 2 spots to the left. So that's a 0.22. And I'm just going to move back here for a second. So remember over here, if it was growth, we're going to add 1 to that value. If it's a loss, we're going to subtract that value from 1. And so this falls into the loss category. So to get our actual b value, we're going to do 1 minus 0.22, which gives us a value of 0.78. Okay, so that's our b value. Okay, and then to get the a value, the starting or the initial amount, we're going to go back to the problem right here, and that is $25,000. So we're going to plug those values in. Actually, we'll do it over here to keep this a little bit cleaner. So y equals, my a value is the starting amount, $25,000, parentheses, my b value, 0.78. You don't need to put the 0 in front. I just like to keep it a little bit, make sure that you realize there's a decimal point there, and raised to the x power. Okay, and again, all we're doing is writing the function, so that's it for this particular problem. Okay, however, on part B, it says use your function to determine what the value of the car will be in 10 years. So we haven't talked about this yet, but this value of x up here, this exponent, is always going to represent time. Okay, so if we're given a value of 10 years, we're going to plug in 10 for x to the equation that we wrote down up here. So we have y equals 25,000, parentheses, 0.78 to the x, and we're going to plug in a value of 10. So now it's going to look like this: 25,000, parentheses, 0.78 to the 10th power, and you would just plug that into your calculator, and you'll get approximately 2,083.94. Okay, so you might get more numbers after the decimal point, but remember we're talking about money, so we only need 2 numbers after the decimal point. So after only 10 years, your initial $25,000 car has depreciated in value to $2,083.94. Okay, so that's the last problem. Make sure you go ahead and redo this review maybe 1 or 2 times just to make sure you're ready for the test on Tuesday. And also remember, if you need to pause it or go back and double check anything, you can go ahead and rewind, pause as often as you need. Good luck on Tuesday, and have a good weekend.